In this session, let's try to look out for the various calculation aspects or analytical aspects associated with the portfolio risk. It can start right from the computations of the portfolio value at risk, and then seeing probably the contributions of the individual securities to this portfolio VAR, and probably we'll discuss about a few more aspects of this VAR called as the marginal VAR and the incremental VAR, how each of them help in terms of the risk management or risk analytics. That is something which we will look out, probably using a data set, and try to understand the different kinds of VARs as a part of our portfolio risk analytics which we are going to do. So when I talk about the value at risk, initially for securities we know how to compute the value at risk. For a equity security, if I want to compute the value of value at risk, all we are talking about is find out the standard deviation of the security and multiply it with the confidence level Z score, the Z score of the confidence level. So if I am going with 99% confidence level, which is 1% VAR calculation, then I will multiply the standard deviation by 2.33, and then I will multiply it with the amount that is getting invested in the same. So that is what is talking about the portfolio, the individual securities value at risk. So for our data, from the data I would like to see, okay, these are the things. The various, I am taking 5 different securities, their prices for the entire year 2013, the daily prices. So I want to find out their daily returns. So probably I'll create new column called returns Tata Motors, right? Or let me call it Tata Motors itself, returns Tata Motors, or similarly I am talking about return HDFC, then I am talking about returns of NTPC, returns Grasim, and I am also taking returns of Hero. Now for each of them I will try to find out their returns, right? That is the way we try to compute the portfolio VAR, or probably first individual security VAR, then I'll try to bring in the portfolio scenario. Okay, for the individual security VAR, first of all I require individual standard deviation. So for that I am trying to find out the individual returns on a daily basis and on a continuous compounded basis. So that's where I am taking log S1 by S0, the today's price by yesterday's price. Right, so this is what is working out as the daily returns. Then similarly I can execute the same for all 5 securities. So these are the returns associated with all the 5 securities over a 5-day period, converting it into percentages with a gap of 2 decimals. Then now this is where if I want to find out the VAR, individual level VAR associated with each of the securities. So let me have these 5 securities here. I'll take it somewhere here, and my intention is to find out the individual level VARs. So if at all I have to find out the VAR at an individual level, I first require the standard deviation. So either I take the daily standard deviation first and then multiply it by square root of 250. So I'll first directly use annual standard deviation. When I'm talking of annual standard deviation, here I'm taking the daily standard deviation, and multiply it with either square root of 250 or 252 kind of number. So annual standard deviation comes out to be this particular number for these 5 securities. So straightforward, it is coming out that Tata Motors has been more and more volatile during the period, whereas the Grasim is comparatively much less volatile during the same period. Right, Grasim is less volatile during the period, whereas the Tata Motors was much more volatile during the period. So I require the annual standard deviation. Now let's assume, for the purpose of doing some computation, let me assume that I am investing the same 100,000 in each of the securities. So investment for time being, right? You can change the numbers very well. So for time being, I would like to understand that I am investing the same 100,000 in each of these 5 securities. That which means my portfolio investment overall is 500,000, right? And which means the weights of each one as a proportion of the total, weights of each one as a proportion of total. Let me just check the weight of this as a proportion of this. Yes, this is 20%. So the weights of all these items are 20%, right? Now, if I want to find out the 1% VAR or VAR at 99% confidence level, then all I am taking is the standard deviation, multiply it with the invested amount, and multiply it with the multiplication factor, which is the Z score associated with 99% confidence level. So that way it is giving me that for the 100,000 that I am investing, the 1 yearly VAR, the 1 yearly value at risk on the 100,000 that is being invested, it is going to be 81,044 is the annual VAR associated with this example. And similarly, when I am talking about HDFC, it works out to be somewhere around 77, right? So there is a 1% chance that in 1 year my loss will be more than 81,000 when I invest in Tata Motors, can be more than 67,000 when I go for HDFC, 65,000 when I go with NTPC, and 55 and 63 respectively. Right, so these are my individual level VARs. These are my individual level VARs associated with all these 5 securities. Right? So that is what is the definition of individual VAR. We are taking their corresponding standard deviations. Of course, here it need not be annual. Whatever the period, whatever the VAR I am interested in, I'll take the standard deviation for that particular period. Right, even if I compute the daily standard deviation, I multiply it by square root of something to get that period standard deviation. So all I require is the standard deviation for that period, and then the confidence level, that score. If I am looking at 1% var, then I require 2.33, which is the value associated with 99% confidence level. And then I am also looking at multiplying it with the amount that is invested in that position. So just an addition to that, if someone is talking about undiversified var, now for the portfolio, for this entire portfolio, if I want to find out the undiversified var, undiversified value at risk, it is nothing but it's the summation of the individual vars, a direct summation of the individual vars. So we'll say the undiversified 90 at 99% confidence level, at 99% confidence level, we are saying that the value at risk is 332,653. This is what we are calling as the undiversified var. But we have to understand that there could be a lot of diversification benefit because of the correlations that are existing between these various securities. So we can actually try to find out the correlations that are existing between the returns of these various securities, and even try to come out with a portfolio var, right? Or the portfolio var, how do I get? I can try to find out, first of all, the portfolio returns I can compute now, right? The portfolio returns I can very well compute, which is nothing but the weightage. So the weightage multiplied by the particular return. So weightage multiplied by particular return, like that we can do a sum product. So what I'll do is I'll do a sum product wherein I'm trying to multiply these weightages by the appropriate returns, and let's say coming out as the return on portfolio. So I'll take this as the return on the portfolio, right? We'll talk about the other way of looking at it also. So this is the return on the portfolio. So here also I will try to accommodate the portfolio, wherein I'll use the same formula, the standard deviation multiplied by square root of 250. So the portfolio annual standard deviation is this much, which means I am investing overall a summation. If I am investing an overall summation of this much, 500,000, probably my portfolio var here is becoming only, my portfolio var is becoming 221,000. Portfolio var is becoming only 221,000, which means almost 111,000 is the diversification benefit that I got using this equal weighted portfolio of 20% each. The other way of finding out the portfolio standard deviation, here I have directly taken the returns and got it. But otherwise, the portfolio variance, we had formula, right? the portfolio variance was nothing but W1 squared sigma 1 squared plus W2 squared sigma 2 squared plus 2W1 W2 sigma 1 sigma 2 into the correlation, or probably these three combined together, which is the covariance between the 1 and 2 security. So doing that kind of an aspect, I can find out the variance of the portfolio, and from there the standard deviation. Probably if a raw data is available, I can find out the standard deviation of the portfolio in this manner, but otherwise I can find out the variance of the portfolio using that particular approach, right? Well, so for that we prepare a variance covariance kind of a matrix, right? So to prepare that variance covariance matrix, I can take these 5 securities here, and at the same time I will take these 5 securities here also. So between them I want to find out the variance and the covariance. So for that all I am taking is, okay, first I will try to find out the variance, right? I will try to find out the variance of each of these securities returns multiplied by 250. So that is the variance associated with each of these security returns. Similarly, for HDFC, I can find out the variance associated with this return multiplied by 250. I'll take it along the diagonal. So the variance of NTPC multiplied by 250, then variance of Grasim multiplied by 250, and similarly the variance of the Hero Motors multiplied by 250. So this is our computation of the various variances. Then we are trying to even compute the covariance associated with each of them, right? Variance covariance kind of a matrix. Okay, so I'll take covariances of each one. So Tata Motors versus HDFC, variance covariance. So this is the covariance associated with these two. Similarly, I can try finding out the covariance between the Tata Motors and NTPC similarly, and the covariance between the first and the fourth security, and the covariance between the first and the fifth. Okay, so these are the associated covariances, and probably in case of HDFC it is nothing but the opposite of this, right? Because covariance between HDFC and Tata Motors will be the same as Tata Motors and HDFC, because the order does not matter in case of covariance. So here we are also talking about, let's say for the others, HDFC versus NTPC, all the other combinations, let's finalize. Covariance between this and this multiplied by 250, covariance between this and this multiplied by 250, covariance between HDFC and Hero Motors multiplied by 250. So here also I can have this value, and here I can have this value. Alright, and even this I am trying to find out the covariance between NTPC and Grasim multiplied by 250, and covariance between NTPC and Hero Motors multiplied by 250. Here again, this is what is my covariances across each of these situations, and here I'll find once again the covariance between Grasim and Hero Motors. Okay, this is the covariance. Okay, I have to multiply this by 250. Okay, so this is what it is. So this is what we call as variance covariance matrix. Right, between these securities, we are saying this is the variance covariance matrix. Now, using this, I can very well find out the portfolio VAR or the portfolio variance. First of all, before I get into the portfolio VAR computation, I can find out the portfolio variance by taking this matrix which has W1 sigma 1 kind of stuff. So all I can do here is I can do a matrix multiplication, right? I can do a simple matrix multiplication here by considering the weightages. So probably I'll take this weightages, the amounts that we have invested, 10,000 or 100,000, right? This is the array I will consider 1. This is the array I will consider 2, and even these weightages I will take in the column format, because our formula, if you see, our formula for W1 squared sigma 1 squared plus W2 squared sigma 2 squared plus 2W1 W2 covariance between 1 and 2. So the way we are writing it in the matrix form is W1 W2, will write it as one array. Then sigma 1 squared, which is the variance. Then I take the covariance. Here also I have taken the covariance, and here sigma 2 squared. So this is nothing but the variance covariance matrix, and this again I will multiply with W1 and W2 here. Now what is coming out? W1 sigma 1 squared. Now if I multiply, let's say these two, it becomes W1 sigma 1 squared plus W2 covariance. And this is a 1 row 2 column matrix. This is a 2 row 2 column matrix. So the multiplication of these two will give you 1 row 2 column matrix. So the first one is that one. The second one is W1 into covariance plus W2 sigma 2 square. Now this you are multiplying with W1 W2. So the direct multiplication of this is, so actually here instead of multiplying like this, first we will multiply this way, First we will multiply these two things. We have to come from the right. So W1 sigma 1 squared plus W2 into W1 sigma 1 squared plus W2 into covariance, and this is becoming W1 covariance plus W2 sigma 2 squared, and this is getting multiplied by W1 W2. So this is directly becoming W1 squared sigma 1 squared plus 2W1 W2 covariance plus W2 sigma 2 squared. So to give this kind of to get this kind of formula directly, I can use a matrix notation of this form. So W1 W2 the weights or the investments can very well be in the form of three matrices. The first one being the investment in a row form, then the second one being the variance covariance matrix, and the third form being the same investments in a column form. So based on that we can get the portfolio variance, not VAR. Portfolio variance is what we can get directly by, you can do a matrix multiplication. First I can consider this one as well as this. So this is a 5 by 5 matrix and this is a 5 by 1 matrix. So your resultant will be a 5 by 1 matrix. So what I can do is, before I apply the formula, because it's an array group of formula, I will select a 5 by 1 matrix. Then I apply matrix multiplication by taking this as one set of values and this as another set of values, and do a control shift enter. So these are the W1 variance covariance matrix multiplied by W1 and W2 and W up to W5. Then we have this matrix multiplied with this matrix. So that is what will give you my overall portfolio covariance. So because this is a 1 by 5 matrix, this is a 5 by 1 matrix, the resultant will be a 1 by 1 matrix. So I can simply select this as one array, this as the other array, and say this is my portfolio variance. So from here I can find out the portfolio standard deviation, which is nothing but the square root of the above number. So this is the portfolio standard deviation. And from here I can find out the portfolio VAR, which is nothing but the confidence level Z score 2.33 times the portfolio standard deviation. This time the standard deviation is not in the form of percentage, so I don't need to multiply it by the total investment, so I can directly take it as it is, which is working out to more or less exactly the same figure that we have got, even when I have directly substituted it as a part of the return. If I don't have that raw data, and if I just have one number about the returns and covariances, if I have raw data, just substituting it, I can easily get my portfolio standard deviation, from where I can compute the portfolio VAR. But if I don't have the raw data, I just have a summary of their returns, variances and covariances, then it's better to obtain the portfolio VAR through this kind of a mechanism. So this is what is the overall portfolio variance, which means this is the undiversified VAR. If at all the correlations were pretty strong between the securities, if the correlations were very close to 1, it is like the overall VAR of the portfolio would have been 332,000, but right now because of the diversification, the portfolio VAR with 99% confidence level has come out to 221,587 only. So these are the things associated with the portfolio VAR. Now, a few more things under the same context. Incremental, marginal, component. Some of these things that are very much required to be understood. So first let me start off with the marginal VAR. See, if I am making an additional investment to the portfolio, if I am making an additional investment to the portfolio, by what extent is the VAR changing for that? By what extent is the VAR changing for that is what we are trying to understand by the marginal VAR. So, what I can do to compute the marginal VAR for each of these securities, right? We'll try to compute the marginal VAR for each of the securities. What are we saying? The per unit change in the portfolio VAR because of the additional investment in a particular position. Like if I want to add some 10,000 bucks to each of these or one at a time. If I just want to add some 10,000 bucks to Tata Motors or 10,000 bucks to HDFC. So by adding some 10,000 bucks or some amount, some additional investment to one position, what is the change in the VAR of the portfolio for $1 addition to a particular investment? What is the change in the overall portfolio? So for that, a straightforward mechanism to look at is I can go with the confidence level Z score, covariance that is existing between the security returns and the portfolio returns. Okay, let me now look at the covariance with respect to the portfolio. Each security covariance with respect to portfolio, which is nothing but the covariance of the securities returns. These are the covariance of the securities returns versus the portfolio's returns. This I need to multiply by 250. So this is the covariance of the securities returns versus the portfolio returns. Now all we are saying is this is the covariance of the securities returns with respect to the portfolio's returns. What we see is at least for these three securities the covariance is more or less the same. It is much higher in case of Tata Motors. Now what we are saying is if I have to compute the marginal VAR, I take or even I should have taken the standard deviation of the portfolio, which is nothing but the same thing. If I had gathered it, this becomes the variance of the portfolio. So because the covariance of portfolio with respect to portfolio is nothing but the variance of the portfolio, I divide it by I take the square root of it, I get the standard deviation of the portfolio's returns. Okay, so this is the standard deviation of the portfolio return. Now straightforward, if I want to know the marginal VAR associated with each of these 5 securities, if I am talking about the marginal VAR associated with each of these 5 securities, all I need to take is the confidence level Z score 2.33 multiplied by the covariance between these two. So this is the covariance between these two divided by the standard deviation of the portfolio. The standard deviation of the portfolio is going to be this number. Now all we are saying is if there is a $1 additional investment in Tata Motors, the VAR is going to increase by 0.55. Right? If there is an additional investment of $1 in Tata Motors, I am expecting that the VAR will increase. So here, keeping all others constant, if I am just investing $1 additional in Tata Motors, this is what is causing the VAR of the Tata Motor. This is what is the increment to the VAR. The same way I can look out for the investment in HDFC, NTPC, Grasim and Hero Motors. So these are the marginal VAR. So if I am investing 10,000 bucks in each one, probably the additional 10,000 bucks if I am investing, the marginal VAR, so the overall VAR is going to be increased by this much per, so if I am investing 10,000 in Tata Motors, probably the VAR is going to be more by this much. So this is what we are calling as the marginal VAR. But on the other side, we also have this is the additional contribution of this particular security to the overall portfolio, assuming the other changes do not exist. But a better version of marginal VAR is what we call as incremental VAR. What we do in the incremental VAR, probably directly change it. Right? Directly I want to change, instead of 100,000, okay, here let me take this portfolio VAR fixed somewhere. Right? I'll take this portfolio VAR fixed somewhere. Now what I would like to see is, okay, if I am investing 110,000 in this, if I am investing 110,000 in this without changing anything else, my portfolio VAR has actually become 227178 or probably 179. That is what has been the change to the portfolio VAR. And the difference between these two is what we call as incremental VAR. 5591 is the incremental VAR. Whereas here, okay, I could have modified these numbers earlier. Let me just go back. Let me just freeze these numbers. Right, these were the marginal VARs. 5513. Probably if I just do a copy paste. Right, so 5513 was the marginal VAR initially, but now assuming if I make it 110,000, I'm seeing that this is becoming 227179. So the incremental is this minus this, which is 5591, whereas earlier it was only 5513. So that is what we are calling as incremental VAR. Why are these two different? Because by bringing in the incremental VAR, we are looking at the overall change. The reason being, see, when the VAR changes or when the new investment comes in, the percentages are changing. This has become 22%. Whereas all these, probably if I am if I'm increasing the percentages, I see that this is 21.5, whereas all others became 19.6. And because of that, even the weightages that are coming up, W1 squared and all these things that come as a part of the computation of the portfolio variance and then the portfolio VAR, it even considers non-linearity in the numbers. So we are actually, when I am talking about incremental VAR, we are looking at it as the overall portfolio value. We are as good as we are doing a full revaluation and seeing the difference between the new VAR and the VAR before the addition of the position, just like the way we have looked at now. Initially the VAR was 221,000, but the moment I have added 10 more thousand to this Tata Motors, the VAR has become 227,000 and adding up a difference of 5591, whereas the marginal VAR in this case was only 5513. So what we also see is, in general, we see that it will be greater than the marginal VAR, and there is a non-linear, because the marginal VAR considers the direct linear relationship only, whereas the marginal VAR, the incremental VAR, is even focusing on the non-linear relationship because of the square of the weights and all those things coming up. The non-linear relationship is also taken into consideration. So what we generally see is the incremental VAR will be greater than the marginal VAR. And the better way to arrive at the incremental VAR is do a full revaluation of the portfolio, just like the way we have done now. Subtract the previous VAR and take that difference to be the incremental VAR of the position. So that is how we have to differentiate between the marginal VAR and the incremental VAR. And what we are simply, the other thing what we are trying out is the component VAR. So it is nothing but VAR of the individual component in the overall scenario. We know that these are the marginal VARs, right? Originally, okay, let me go back. Let me make it 100,000. So these are the original VARs. The marginal VARs are these numbers. All we are talking about is take the marginal VAR multiplied by the amount invested in that position. So we don't need, this is my marginal VAR. So marginal VAR multiplied by the amount invested in that position is called as the component VAR. If we see the point here, when I take this and I multiply this with my position, so this is what is contributing. Oh, here I should have taken 100,000 then. So this is what is contributing as my component VAR. So to the overall portfolio, all I am seeing is this is the additional contribution that is coming up. Right, to the overall portfolio, this is the contribution of each of the components to the overall. So what do we mean by that? If we had added up all these things, this would have given the diversified portfolio VAR itself, which is nothing but, if I want the component VAR, you take the diversified portfolio VAR and multiply it. You take the diversified portfolio VAR and multiply it by the marginal contribution, the proportion of the marginal contribution, which is nothing but this divided by the summation of all these, which is nothing but the marginal var. So I can link the marginal var with respect to the component var using this kind of a mechanism. And one more thing is, I could have taken the beta. See, even for the marginal var we are talking about this formula, right? The Z score multiplied by the covariance between the returns of the security and the return on market, return on the portfolio divided by standard deviation of the portfolio. For some extent, you assume the portfolio to be the market. So what is this formula? Z score into covariance of return on security, return on portfolio divided by, you multiply the denominator with standard deviation of portfolio and even the numerator with the standard deviation of portfolio. Then this becomes the beta of the security with respect to the portfolio. So Z score multiplied by beta of the security with respect to portfolio multiplied by the standard deviation. Now we know that the variance of the portfolio or value at risk of the portfolio is nothing but the Z score multiplied by the standard deviation of the portfolio multiplied by Z score and multiplied by the amount invested in that particular position or amount invested in the portfolio, because this is for the portfolio. So if I really want Z score into the standard deviation of the portfolio, this is nothing but the value at risk for the portfolio divided by the portfolio value multiplied by the beta of the security with respect to the portfolio. So we can try finding out the beta of the security with respect to this portfolio here. So if I try to find out here the beta of the security with respect to the portfolio, which is nothing but the covariance with respect to the portfolio divided by the variance of the portfolio. That is what is the beta. Okay, so in this case the beta is coming out to a number 1.24, and for each of them the betas are 1.12 and probably 0.88. So which means I could have got even the marginal var using the beta kind of a formula also. I could have got the marginal vars even as the variance of the portfolio or value at risk of the portfolio, which is this value at risk of the portfolio divided by the total portfolio value, which is 500,000, which I will take from here. I take the portfolio value. I multiply these with the beta of the portfolio, beta of the security with respect to the portfolio. So even in this case we get the marginal var to be this kind of a number itself. This is what is the computation of the marginal var either from the covariance or given the beta. The same way we can think of the component var also. So these are some of the different calculations that are associated with the value at risk, especially with the portfolio, and how can the portfolio can bring down portfolio because of the diversification benefit how can it bring down the value at risk for the overall portfolio? Right. Now, as we have already computed all these kind of VARs, now let's look at a bit of more details into the content inside it, or the concepts inside it. So how do we compute the VAR? We have simply said it is nothing but the z value corresponding to a confidence interval multiplied by the standard deviation, whether it's a security or of a portfolio, and multiplied by the amount that is actually invested in that position or portfolio. So this standard deviation is nothing but the square root of the variance. So the standard deviation of the portfolio, we know that we can compute it as W1 squared sigma 1 squared plus W2 squared sigma 2 squared plus 2W1 W2, the covariance between the 1 and 2. This is what is the sigma formula, sigma for the portfolio. So if I directly take ZC into this, into the amount, now all that is coming up is, if I ignore the amount part, right, or even if I keep the amount part, what is coming out is this amount, let me talk of as a portfolio. Now probably if I carry this also into the square root, so it is becoming the Z score squared into the amount squared into this entire thing, right? W1 squared sigma 1 squared plus. So all, if you see, if at all the correlation, now let's bring in the correlation factor, because covariance is nothing but correlation between 1 and 2 multiplied by sigma 1 into sigma 2. So assume that the correlation is 0. So this entire term is becoming 0. So all it is coming out is W1 squared sigma 1 squared plus W2 squared sigma 2 squared. So if you expand it, this is nothing but, right, this the entire, in the inside one, so ZC into amount into its portfolio amount into its weightage, which is nothing but the value of the position invested in that particular security, into this. So this is nothing but the var1 squared. So var1 squared plus var2 squared. So that is what we are saying. If the correlation between the two securities is 0, the portfolio var is nothing but it's the square root of sum of squares of the individual var. The same way, if this had been 1, the inside one would have become W1 squared sigma 1 squared W2 squared sigma 2 squared plus sigma 1 plus 2 W1 W2 sigma 1 sigma 2, which internally is nothing but ZC into P, or amount invested, multiplied by W1 sigma 1 plus W2 sigma 2. This is what is coming out. Now expand it. This is nothing but var 1 plus var 2. So this is nothing but the undiversified portion of the var. If at all the correlation between the two is 1, the overall portfolio var is nothing but the sum of the individual vars of the various securities. So in this case, what we are seeing is, if the correlation is higher and higher, we are not going to get any kind of a diversification benefit, which means there will not be much change between the diversified var and the undiversified var. When we are seeing that the correlation is very high, close to 1, we say that there is no diversification benefit, because a good portfolio should typically have the correlation much lesser, probably closer to 0, or in some cases negative also, would bring down the portfolio variance, which means the portfolio value at risk also will actually come down. So the diversification benefit is lesser if the correlation is higher and vice versa. Though that means even the change in the diversified value at risk also will be much lesser if the correlation between the securities is much higher. So probably just a quick workout. Let's say here I'm talking about two securities, right? Or probably three securities. What is the variance of the portfolio here? All we are talking of is W1 squared sigma 1 squared plus W2 squared sigma 2 squared plus W3 squared sigma 3 squared plus 2W1 W2 covariance between 1 and 2 plus 2W1 W3 covariance between 1 and 3 plus 2W2 W3 covariance between 2 and 3. Now here is where I make an assumption. I assume if the portfolio is equal weighted. So in this three case, what could have happened? A simplification could have happened, which is 1 by 3 squared sigma 1 squared plus 1 by 3 squared sigma 2 squared plus 1 by 3 squared sigma 3 squared plus 2 into 1 by 3 into 1 by 3 because we are talking about an equal weighted portfolio. Covariance between 1 and 2, the same way it works, plus 2 into 1 by 3 into 1 by 3 covariance between 2 and 3 and 2 into 1 by 3 into 1 by 3 covariance between 1 and 3. Now this is nothing but 1 by 9 times the summation, which is also probably you could have written it as 1 by 3 into the average of the variances, variance bar. See, 1 by 9 I will write it as 1 by 3 into 1 by 3. So it will come out as 1 by 3 into 1 by 3 of all these, which is nothing but the average of the variances plus 2 by 3 into average of the covariances. So here 2 into 1 by 3 if I take out, then the average of all the possible covariances. So the other way is the covariances are basically dependent on the correlation, and so in this case probably this 3 could become 4, 4 could become 5, 5 could become, in general probably the variance of the portfolio for an equal weighted you can write it as 1 by n times the average of the variances plus n minus 1 by n times the average of the covariances. So covariances are purely linked with the correlation. So if this overall, this is the portfolio variance for an equal weighted portfolio. So if the portfolio variance has to be lesser, two things, either n has to be much higher, so the number of securities in the portfolio should be high, which means as the number of securities increases, portfolio variance and thus the portfolio VAR will decrease, or there should be less correlation between the securities. If the correlation between the securities is much lesser, even that would result in reducing the portfolio VAR. So two things for reducing the portfolio VAR: increase the number of securities. That's the first thing to reduce your portfolio VAR. And the second thing is identify the securities where the correlations between them are much smaller. These two will play an effective role in reducing the overall value at risk of the portfolio. So that is how we should understand the relation, the correlations between the variables in order to get a very good clarity with respect to the portfolio's value at risk. All right. So another point to understand in this context is, though on one side we say that as the number of securities in the portfolio, right, number of securities in the portfolio increases, the value at risk or portfolio variance, first of all, portfolio variance will decrease, so the portfolio value at risk also should decrease. But the biggest thing is, the moment I add more and more securities, probably hundreds of securities to the portfolio, one, the value addition in terms of change in the portfolio VAR, which is the incremental VAR. Let's say I already had 100 securities in my portfolio. I have added the 101st security. Whatever is the excess VAR that is coming up, whatever is the incremental, or probably whatever is the incremental advantage, diversification benefit that I am going to get, probably will be very nominal. And on the other side, the covariance matrix goes very much, because earlier with 100 securities, probably the covariance matrix is just 100 by 100 matrix. Now it becomes 101 by 101 matrix, where almost 200 odd new elements are getting added. 201 new elements are getting added, because this requires only 10,000 elements, whereas this requires 10,201 elements. So almost 201 new elements are getting added, and that is what will create too much of computational headaches, and because of that, probably too much of time consuming, even if we are using any level of effective system. So we have to be really careful to take a call beyond which it's not advisable to increase the size of the portfolio, as one, the diversification benefit may not be that heavy, and at the same time, even though we use any level of powerful systems, it can really consume too much of time, and the covariance matrix really increases quite drastically. So that's one thing we have to keep in mind, though we are able to reduce the portfolio VAR along with the increase in the size of the portfolio. Now, another interesting thing to look at in this context is, how do I use the concept of marginal VAR to take my investment decisions? Where to invest, where to pull out, how to adjust the composition of the portfolio, all these things will be decided based on the marginal VAR itself. So we'll look at in our example also, but just to look at it on a broader scale, what we are saying is, you reduce the weight or proportion in those securities which have higher marginal VAR, and allocate them to those securities which have lower marginal VAR. So going back to our example, we know that this Tata Motors is having a higher marginal VAR, whereas probably one of these three out of these, let's say NTPC is having the lower marginal VAR. Now what we are saying is, it's better that you allocate. So let me copy these numbers somewhere. I'm copying these numbers somewhere here. Now what we are saying is, it's better that we allocate let's say 10,000 lesser from here and increase the 10,000 here. Now let's see what is happening. If I pull out, okay, I include 90,000 here, but I make 110,000 here, saying I'm pulling out some position from a higher marginal VAR security and investing in a security with a lower marginal VAR. The result is the portfolio VAR has come down now. The portfolio VAR now became 220, 156. The portfolio VAR has come down, and even look at your marginal VARs. Okay, here this has come to 0.52 and this has got increased to 0.40. Now earlier gap got almost reduced. Now let's do something more. Make it 80,000 here, but make it 120,000 here. Right? The overall VAR is now still got down to 219. The portfolio VAR has come down to 219,000. And at the same time, you could see this has come to 0.5, this has come to 0.42. Now again, probably here I will try to increase another 10,000. So I'll decrease this, let's say, to 70,000 and I can increase to 110,000. Again, the portfolio VAR came to 218 and even the overall numbers 0.48 and it has come to 0.39. So this kind of an adjustment has to be done. So the portfolio adjustment will happen and my investment decision can be taken based on this mechanism. And if I want to bring out the global minimum risk kind of a scenario, a global minimum risk portfolio, the ideal scenario always is make sure that the marginal VARs of all of them are equal. If I see that the marginal VARs of all these securities are equal, marginal VARs of all these securities are equal, that is what will result in a global minimum kind of a portfolio. Right? So the better way to achieve that is reduce your positions from those securities which have a higher marginal VAR and increase the positions in those securities which have lower marginal VAR. You see that the marginal VAR for that the higher marginal VAR keeps coming down in that case and the lower marginal VAR will keep going up. So do it until the marginal VARs of all the securities in your portfolio are equal. You can actually use some kind of optimization kind of tools like solver in Excel, which can help you to attain that kind of a scenario. But conceptually, what we are looking at is we can create a global minimum risk portfolio where the marginal VARs of all the securities are literally equal. Okay, so probably let's try out using Excel how we can get that. So I'll use a solver kind of scenario, right? My intention is reduce the error between all these marginal VARs. So these are the marginal VARs, right, for each one of them. So I want, if at all of them have been equal, that is the position where that is the amount that are worth investing in this particular portfolio. Keeping in mind that I have to invest the entire 500,000, I want to know which proportions I should invest so that my overall marginal VAR comes to be all the marginal VARs of all the individual securities, they are equal. So to create that kind of equality kind of a scenario, what I would do is I'll create one element called error, which is nothing but I will take it as the difference in the marginal vars of all the pairs. I'll take the squaring. I'll take the difference in the marginal vars of all the pairs as a square. Let's try out. I'll take the difference of all the pairs possible. We can have some other formulas to try to address that. Right, I'm taking the squares of the difference of all the marginal vars which are currently existing. All right, these are the errors with respect to all the marginal vars pairwise. So if all the pairs are equal, then the value would have been 0, right? Then the value would have been 0. So I'm doing the squaring and saying this is the current error. Now using a tool like solver, what I would like to do is I want to make this as much minimum as possible. So the lowest possibility is 0. So I will use a tool like solver saying this should be 0, and I want to play around with this combination. I want to play around with this combination and probably setting this total value equal to 500,000 as a constraint. So let's try working out if we are able to do it. So as a part of my objective, I will set that the error term should be equal to 0 or probably the minimum most possible, and that I want to achieve by changing the amounts that I am planning to invest in each one of them. And one constraint I am saying is, yeah, the sum should still be 500,000. It cannot be more than that or less than that. Right? So this is one criteria I am going with. Right? And probably all these amounts, yeah, we'll add one more criteria saying all these amounts should definitely be greater than 0. Otherwise it may give some kind of short positions also for me, which right now I don't want to look at. So I will take it as all these numbers should be greater than 0. One more constraint I'm trying to put. So probably I just want to solve this to see if the solver can really take care of this solution. If it is able to give me something close to 0, that is a weightage that is going to minimize my risk overall. If I am looking out for an investment in this particular combination of securities, yeah, solver has tried to give a solution where the error is almost 0. If you see here, the marginal vars, probably I take it as a rounding up to 2 digits or something. We see 42.86 more or less is the marginal var in all of them, and what we could see here is the beta for all of them with respect to portfolio is 1, and this is the amount that it has suggested is worth investing. Keeping your 500,000 in mind, this is the amount that is worth investing in each of the securities. So it is talking about putting 50,000 in Tata Motors, 42 in HDFC, but increase the investment to 120,000 in NTPC, 150,000 in Grasim, and 137 in Hero Motorcorp. So that is how we can use tools like Solver to really take portfolio investment decisions by creating a global minimum risk kind of an investment scenario also. So that is where we can take the help of marginal VARs to make our investment decision. If not the minimum most, probably I can try playing around with my overall portfolio VAR, reduce my overall portfolio value at risk by trying to pull out some position from that particular security whose marginal VAR is higher and invest in that position whose marginal VAR is lower. That is one more dimension that we need to focus upon. But one thing here we have to note that achieving a global minimum risk portfolio as we have got in our Excel sheet, it doesn't mean that that portfolio is optimal, because probably I may take slightly more risk to get much more return. So when we talk about the portfolio management, our intention is not just to reduce the risk, but our intention is even to assess the risk in context of the return also. So I am not just targeting a global minimum risk. When I am using risk management, my intention is to reduce the risk drastically by using various mechanisms and methods to address the risk. But when I am talking in the context of portfolio management, I am more interested in even looking at the returns and based on the returns doing an adjustment for the risk. So that's where probably, if we remember, we generally use Sharpe ratio in portfolio management, where we talk about the portfolio return minus some benchmark, which is the risk-free rate of return, divided by the standard deviation of the portfolio. This is what we were using. And when I say optimal portfolio, it is that portfolio which will maximize this Sharpe ratio. That is what we called as the optimal portfolio, which means in this context now, probably I could have even done probably RP minus RF divided by the VAR of the portfolio, even this, because this is nothing but standard deviation multiplied by 2.33 multiplied by the amount invested. As these two things are constant, I could very well do this as a modified Sharpe ratio, wherein instead of taking the standard deviation in the denominator, I could have taken the value at risk of the portfolio in the denominator itself. Now, if at all I am talking about an optimal portfolio management, my intention is to maximize this value, not the minimize the total error or something. My intention is to maximize this value. So let's try if we can do the same in our spreadsheet. For that, just for a quick understanding, what I am thinking of is I will assume some returns which I am expecting for the next year on these securities. Okay, I am expecting some 22% on this, right, and some 19% on this, some 16% on this, just assigning like that. Some 13% on this and some 10% on this. Let's say these are the returns that I am looking at on these securities for the next year. Now, if these are the returns that are getting expected on these securities, now my intention is to compute this particular value, the portfolio return minus the risk-free rate of return divided by the standard deviation or probably the VAR of the portfolio. So I can look out for a Sharpe ratio in this case, which is nothing but the return on the security minus, probably here I'll assume that the risk-free rate of return is somewhere around 7%. So here itself, let me take for these securities the Sharpe ratio, wherein I am looking at the risk-free rate of return minus where I am looking at the portfolio return minus the risk-free rate of return divided by the standard deviation of the returns. This is what is the standard deviation of the return. So this is what are the individual Sharpe ratios. Now if I want the portfolio's Sharpe ratio, it is nothing but multiply the weightages with that particular Sharpe ratio, right? That is what will give me the portfolio Sharpe ratio. So I'll simply go with some product of these Sharpe ratios with their corresponding weightages, which is giving me somewhere around 0.26, or probably I could have computed the portfolio return itself here. What is my portfolio return? These returns multiplied by the weights. Okay, so let me try out. The portfolio return is nothing but these returns multiplied by their corresponding weights. So this is what is coming out as the portfolio return. So the portfolio Sharpe ratio is nothing but this particular overall portfolio return minus 7% divided by the portfolio risk. So this is my portfolio's variance. So I take the standard deviation of this. This is what is the portfolio risk. Okay, so there's some issue in our calculation. This is our portfolio risk, right? Let me not. So this is what is the Sharpe ratio, which is the standard deviation of the return of the portfolio minus the risk-free rate of return, which is 7%, divided by the standard deviation of the portfolio. I have to take the diversification effect also. So the standard deviation of the portfolio, which is resulting in a Sharpe ratio of this much. Now what we are saying is, if at all I want an optimal portfolio, I don't want this portfolio's VAR to be minimized or the error to be minimized. I don't want the marginal VAR to be equal. Rather, I want the Sharpe ratio to be maximized if I am looking at a portfolio optimization. So what I would have used as a part of the same solver tool, especially if my intention is portfolio maximization, optimization, is I would have taken the Sharpe ratio of the portfolio and I would have set it as this as the maximization rule, wherein I'm changing the values and at the same time all of them, so the rules will still remain the same. Now when I'm trying to solve for it, right, in this case at least I got a similar kind of a solution. Maximize okay, for time being, let me try changing all of them to 10,000 only. Something is going wrong. I'll try making all of them as 100,000. So in this case, actually the Sharpe ratio was 0.473, right? So what we should look out for is, let me try using the solver with an objective to maximize the Sharpe ratio, and I want to modify the investments so that the sum of this investments is this much and each of these values is greater than or equal to 0. Let me try to solve for that position. Yeah, I think now it is happening. Okay, something it has come out. Oh, it is saying invest the entire thing in Tata Motors itself because this is the portfolio risk, and if you are investing entirely here, covariance, oh sorry, this is the covariance with respect to the portfolio. All right, I should take, sorry, we have actually multiplied with something wrong. In our return, the return is the individual returns multiplied by the weightages divided by the variance of the portfolio. What is this variance of the portfolio? Why is the variance of the portfolio changing? All right. I require if I take the variance of the portfolio, I'm simply computing this. So the square root of this will become the standard deviation. So what is coming out is if my intention is to maximize the Sharpe, because the Sharpe ratios in all the other ones are these are the individual standard deviation. So what we are looking at is the whole Sharpe ratio is maximum in this case. So the portfolio var is coming out something like this. So probably let me try changing the numbers a little bit. Right, probably if this is 20%, if this is 22, if this is 18, this is 25 and this is 12. Just some kind of changes coming out. And then if my intention again is to look out for maximizing this particular Sharpe. Let's see, I want to maximize this particular Sharpe ratio. There is, we may have to work out a little bit more on it because a few more constraints have to come out. Right, let me see what is going wrong. Okay, in this case, if it is an equal weighted portfolio, the Sharpe is actually coming out to 6.65. So if at all I am trying to do a portfolio maximization now, oh, I think I'm setting the something wrong. This 28, R28 needs to be maximized. Oh, we are doing a maximization of something else. So I want to maximize this by going with this process. Let's see now. Right. This time we should get a better combination. Yeah, this is what it is. Right. So in this case, it is saying the Sharp can be 0.74, and this is where you should assign. You should put 60,000 here, whereas, so probably let me go back to my original calculation: 22, 19, 16, 13 and 10. And then again let me retry the scenario. This time when I solve it, so the solver is really trying out on this. Okay, I'm getting, this time it says at least, okay, try focusing only on the first three securities and not on the other two. And one way I could look out is now the marginal VARs are also different. But when I want an optimal portfolio altogether, it's not the VAR I am looking at. Probably all I am looking at is the ratio here. All I would be interested in looking out in this case is the positions return. What is my positions return here? This is the positions return minus the risk-free rate of return divided by the marginal VAR associated with it. This is what is the marginal VAR associated with that. So what you see is this value is somewhere equal to this much, and if I look at around for across all the securities, this value is lying out to be equal. So it's not the marginal VAR that will be equal, but it is the ratio that, but it is the positions return above the risk-free rate of return divided by the marginal VAR of that particular security. That would be equal for all the positions. That is where we are trying to get an optimal portfolio wherein the VAR is going to, VAR may be slightly higher, but it is an optimal portfolio where we are talking about risk adjusted return is higher for that kind of a portfolio. So that is what is the clear difference we have to understand between the risk management and the portfolio management. So though I am ready to take a slightly additional risk, it should compensate me with a very high additional return, which should result in my Sharp ratio to be maximum. Sharp ratio is maximum at the same time means even if I take the VAR of the portfolio in the denominator instead of the standard deviation, it doesn't make any big difference. So that ratio should be a maximum for me, and whichever combination gives me the maximum value for the Sharp ratio, not the minimum risk necessarily, that is what is my optimal portfolio, which will have slightly higher value at risk, but probably there is a good chance of getting more returns out of that. Risk adjusted return is maximum for that kind of a position, right? So that is what I would like to talk about, the portfolio value at risk and the various calculation aspects associated with the portfolio value at risk. In case you have any further queries regarding the same, you can get back to me by giving me a call on the number that I have provided below, or you can even send in an email at vamsidhar@pacegurus.com. Thanks a lot for listening to this session. Thank you very much.